A polynomial p has zeros when x is equal to -4, x is equal to 3, and x is equal to 1/8. What could be the equation of p? So pause this video and think about it on your own before we work through it together. All right. So the fact that we have zeros at these values, that means that p of x, when x is equal to one of these values, is equal to 0. So p of -4 is equal to 0, p of 3 is equal to 0, and p of 1/8 is equal to 0. And before I even look at these choices, I could think about constructing a polynomial for which that is true. That's going to be true if I can express this polynomial as the product of expressions where each of these would make each of those expressions equal to 0. So what's an expression that would be 0 when x is equal to -4? Well, the expression x plus 4, this is equal to 0 when x is equal to -4, so I like that. What would be an expression that would be equal to 0 when x is equal to 3? Well, what about the expression x minus 3? If x is equal to 3, then this is going to be equal 0. 0 times anything is going to be equal to 0. So p of 3 would be 0 in this case. And then what is an expression that would be equal to 0 when x is equal to 1/8? Well, that would be x minus 1/8. Now, though these aren't the only expressions, you could multiply them by constants, and still the principles that I just talked about would be true. But our polynomial would look something like this. You could try it out. If x is equal to -4, if x is equal to -4, well, then this first expression is 0. 0 times something is 0. Same thing for x equals 3. If x equals 3, then x minus 3 is equal to 0. And then 0 times something is 0. And then if x is equal to 1/8, this expression is going to be equal to 0. 0 times something is going to be equal to 0. So which of these choices look like that? So let's see. X plus 4, I actually see that in choices B, and I see that in choices D. Choice C has x minus 4 there. So that would have a 0 at x equals 4. If x equals 4, this first expression, this first part of the expression would be equal to 0. But we care about that happening when x is equal to -4. So I would actually rule out C, and then for the same reason I would rule out A. So we're between B and D. And now let's see. Which of these have an x minus 3 in them? Well, I see an x minus 3 here. I see an x minus 3 there. So I still like B and D. I'll put another check mark right over there. And then last but not least, which of these would be equal to 0 when x is equal to 1/8? Well, let's see. If I do 1/8 times 1/8 here, I'm going to get 1/64 for this part of the expression. And so that's not going to be equal to 0. And these other two things aren't going to be equal to 0 when x is equal to 1/8. So this one is not looking so good. But let's verify this one. This has, if x is equal to 1/8, we have 8 times 1/8, which is 1, minus 1. That is going to be equal to 0. So this one checks out. And you might be thinking, hey, this last polynomial looks a little bit different than this polynomial that I wrote up here when I just tried to come up with a polynomial for which this would be true. And as I mentioned, you could take this and multiply by constants and it would still be true. So if you just take this and if we were to multiply it by 8, you would get p of x down here. Because if we were to multiply this times 8, which wouldn't change the zeros, well then if you distribute this 8, this last expression would become 8x minus 1, which is exactly what we have down here.